Hi, you guys, and welcome to Chapter 4. You made it! We're going to learn all about graphing linear equations and some different strategies to do that. Today, we're going to start with learning about slope-intercept form. Some of you may have seen this before. This may be brand new for some of you, but I think you are going to find the logic and the patterns intriguing as you see the connection between the structure of the equation and the graph that that equation creates on a coordinate plane. So here we go. So slope-intercept form means that our equation is written in this form y equals mx plus b. And the structure is super important because it tells us two key pieces about our equation. It tells us the slope, and that's always going to be a constant out in front of your x. Could be positive, could be negative, but it's always going to be a constant in front of your x. It tells us the slope. And we will also have a number added onto the end. B is a constant, and that is your y-intercept. So it tells us where this line crosses the y-intercept. So if we are graphing this equation, y equals 3x plus 1, you're going to notice that it is in slope-intercept form. So 3 is our slope, and negative 1 is our y-intercept. So it means if we go right here down to negative 1 on the y-axis, that's where it crosses, and from that point, we're going to go up 3, 1, 2, 3, over 1. Because slope is always rise over run. Okay, which means your change in y over your change in x. Okay? So if we know a point and we know the slope, we can graph a line. So looking at our first equation here, if we know the slope, it would be y equals 7x plus 2 tells us our y-intercept is at 2. So we know it crosses the y-axis at 0, 2, and it's going to go up 7 over 1. Here, if our slope is 1/3, we know that's going to be our m going right out in front of the x, and our y-intercept is negative 1. So it's going to be y equals 1/3 x minus 1. Okay, so we can write the equation of a line if we know the slope and the y-intercept. Now here's an example where our slope is 0. So when our slope is 0, we know 0 times x would just give us 0, which would vanish out of our equation. So we would end up with y equals 9. So for any value of x, y equals 9, and it would be a nice horizontal line. So we would go up 9 on the y-axis, and this would be our line right up here. You'll remember a slope of 0 is a horizontal line. So we would say slope equals 0, and our equation for the line is just y equals 9. We don't have an x value in here because for any value of x, y equals 9, right? In this next example over here, you're going to see that our slope is 1/3. Our y-intercept is at 0, okay? So it's going to cross at this point right here. And our slope means we go up 1 over 3 and put a point there. Then if we were to connect those dots, we would have our line. Okay, so when our y-intercept is 0, it just means it passes through the origin. Okay, if our slope is 0, it means that we have a horizontal line. See the difference? So first you were given the slope and given the y-intercept. Now I want you to be able to solve for this equation of a line if you are only given 2 points. So from any 2 points that are on this line, you should be able to derive the equation. The first thing you should be able to do is find the slope by taking the change in y over the change in x. So you know your 2 points are at 0, negative 3, 0, negative 3, and 4, 3. Okay, so you're going to just call this y1, x1 and y1. And this is going to be x2 and y2 for those two values. So you'll remember slope is change in y over change in x. So let's take our second y and go 3 minus a negative 3, that's our y1, over x2 is 4 minus 0. So that's going to be, the two negatives cancel out, that will be 6 over 4, which we can reduce down to simplest form of 3 over 2. Okay, now as we look at this one, we know our x is 0, so this is actually our y-intercept, right? So our y-intercept is at negative 3. So we know the slope, we know the y-intercept, we can go ahead and write the equation for this line. So that's precisely what they did. They took the 3/2 and put it out in front of the x, that's our m, right, our slope, and our y-intercept is at negative 3. So we have the equation for the line. So next, you're going to learn how to use a graph to write the equation of the line. The first thing you need to look at is, where does it cross the y-axis? And we know the y-intercept is up here at 0, 2. Okay, so our y-intercept is going to be plus 2 in our y equals mx plus b format. Now the slope from this graph, you have to find 2 points on here, right? Where it's going to cross exactly where those blue lines cross, on our grid here. So we're going to go down 1, 2, 3, 3. So that's going to be negative 3 and over 4. Okay, so our slope would be negative 3/4. Now it's important to notice which direction you're going on the y-axis. If you are going down, that is going to be negative. You're moving in the negative direction. So you have to notice that your slope is going to be negative. Another way to think of it is that any line that is decreasing here as you move from left to right, that is going to have a negative slope. So your equation should reflect that, and you should have a negative number in front of your x. So here is another equation that has been graphed, and you are going to write the equation just by looking at the graph. So we know our y-intercept is here at 1, and then we're going to find our slope. We're going to go up 2 over 4. Or we could just go up 2 over 1. So our slope is, I'm sorry, I said that wrong, up 1 over 2. Super important to keep that straight. Sorry, I messed you up there. Up 1 over 2 for a slope of 1/2. So our equation would be y equals 1/2 x plus 1. Again, here you're starting with the graph and you're writing the equation from looking at this graph. We know our y-intercept and we can figure out our slope by going down 2 over 5. So it'd be negative 2 over 5, right? So we see this here, y equals negative 2/5 x minus 1. And that minus 1 reflects that our y-intercept is here at negative 1. Okay, so now we're going to look at the next part 2 here of section 4.1. We're continuing to write equations in slope-intercept form, y equals mx plus b. You guys remember that. Now, I want you to be able to write an equation if you're given just 2 points. So from any 2 points, you can derive an equation in slope-intercept form. The main thing to keep in mind is that you can figure out what the slope is from this. So this is like our y1 and our y2. So we know the slope formula is the change in y, right, over the change in x. So if we take our y2 minus y1, and then our x2 minus x1, which is a negative 3, we're going to solve that and say negative 1 minus 5 is negative 6. 0 minus a negative 3 gives us a positive 3, which reduces down to a negative 1/2 slope there. Nope, I flipped that. That's going to be a negative 2 over 1, which is just a negative 2 slope. So we know our slope, and if we look at our coordinates, we know where this crosses the y-axis. We know where x is equal to 0. So we can go ahead and write the equation of our line, which would be y equals negative 2x minus 1. There we go. So here's another set of coordinates. And the first thing you're going to notice is, hey, they have given me the y-intercept. My y-intercept is where x is 0. And we know that your y-intercept is going to be at negative 5. All right. Now, when you're finding the slope, you're going to notice right over here that they've taken your y2 minus y1 over um, x2 minus x1. So 8 minus 0 is going to be 8. But on the top, we end up with negative 5 plus 5, which is 0. So our slope is 0, and we know when we have a slope of 0, we end up with a horizontal line, right? And we know where it crosses that y-axis is going to be, up here at, that's not it. Here's our y-axis, so this is going to be at 0, negative 5. So our line would be y equals negative 5. In this next example, they've also given you a y-coordinate here because we know x is 0, so your y-intercept is at negative 2. So you're just going to find the slope of the line between these 2 points and write your equation, y equals 3x minus 2. So when you're writing an equation from 2 points and neither one is the y-intercept, it is a little bit more tricky. Okay, so the first thing you're going to do is find the slope, just like they did here, by finding the change in y over the change in x. Now, the most important thing when you're finding slope is to keep track of which is your second point and which is your first point, and not flip-flop those around when you're subtracting the two things. So they found their slope is 4, and then they're going to use one of the points to plug into the equation. So they substitute that point in and say, all right, my y-coordinate is 1. That goes there. My x-coordinate is 2. From that point, they can figure out where this line crosses the y-axis by solving so that the equation is true, okay? So see, they've plugged those numbers in. They say 1 equals 8 plus b. Subtract 8 from both sides, negative 7 is b. So they figured out where that line is going to cross the y-intercept. They already know their slope, and they can write the equation in slope-intercept form. Again, we have 2 points. One of them is not the y-intercept, so they are going to have to first figure out the slope, then write their equation in slope-intercept form, plug in 2 values, okay? So they have 1 point here that we know lies on the line. So they put in 0 for y and 3 for x, and they're solving for what value of b makes this equation true. So once they solve for b and figure out b is equal to 1, then they can plug in the slope that they found up here in this part and write their equation. Do you guys see how that works? It's not so hard. Okay, now here's a flashback to function notation. Remember, when you see f of 0, it means that 0 is your x, so that's your input, and 10 is your output. So you could create an ordered pair from that. So at 0, 10, you have a point that lies on the line for this function. Now at 634, you also have a point that lies on this line. From those 2 points that we derived from function notation, you can figure out, well, first we know our y-intercept, and you can figure out your slope. So you're going to do rise over run, so change in y over change in x, which gives us 24 over 6, or 4. Now when you write an equation for that line, we know our slope is going to be 4, and our y-intercept we found up here because when x is 0, y is 10, so our y-intercept is at 10. So the function, instead of writing y, we can just say the function of x equals 4x plus 10. And you see that f of x is really standing in for what we were used to seeing as y. So here's one more quick function example. Just remember, when x is 0, y is 9, or g of 0 is 9. And when x is 8, g of 8 is 7, or we have an ordered pair 8, 7. You guys see that there. So those are our ordered pairs 8, 7, 0, 9. We do the change in y over the change in x and end up with negative 1/4 as our slope. And we know when x is 0, y is 9, so we have our y-intercept. And we have the equation for this function. So a linear model is just a function that models a real-life situation. So if you study more time, your grade increases, right? You could graph that probably. So when it changes at a constant, when a quantity y changes at a constant rate with respect to x, you can use our slope-intercept form to model the equation, the y equals mx plus b. The value of m is a constant rate of change, okay? And the value b is the initial or starting value of y. Now, this is super important because we don't just play with numbers to make pretty graphs, but we play with numbers because in real life there is beauty and symmetry and patterns, and we see this happen in real life. So let's look at some examples. Okay, hydropower. We live in this beautiful place with two dams so near to our town. And hydropower is what runs our homes, what lights our lights. And so, hydropower plants use renewable energy sources to generate 105 million megawatt hours of electricity in 2007. 5 years later, in 2012, the amount of electricity increased to 219 million megawatt hours. That is crazy. Write a linear model that represents the number of megawatt hours generated by non hydropower renewable energy sources as a function of the number of years since 2007. So we are assuming that the increase was from non hydropower renewable energy sources like wind, solar, all that great stuff. So we're going to use our model to predict the number of megawatt hours in 2017. So if we look at our data, we know how much was produced in 2007, 105 million megawatt hours. That is a lot of power. And 5 years later, they had 219 million megawatt hours. Now we're asking 5 years from that point, how much power would we estimate would be generated? So we're going to derive an equation from our line. And you see that we have kind of our x value and our y value if we were to graph this. So let's make sense of this problem. We know where we started was at 105 megawatt hours. Okay, so in 2007, we were at 105 million megawatt hours. In 2012, we were at 219. So this would be 5 years later. 219 is going to be about right there. So if we were to connect those dots, we could use our graph to predict where more or less we would be in 2017. So we're estimating somewhere upwards of 300 million megawatt hours. Now, if we were to look at this data, we could figure out our rate of change. So we would say 219 minus 105 over 2012. Keep my y2 straight, minus 2007. So we know this would be 114 divided by 5. Now, if we were to plug that into an equation, do we know our y-intercept? Yeah, that was our starting value at 105, okay? And our rate of change would be this. Now we could make that into prettier form. So doing a little math, we find that that is equal to 22.8. So that's the increase from year to year. So our equation would be y equals 22.8x plus our y-intercept here was at 105, 105. So from that, for 2017, we could figure out how many million megawatt hours they make there. Now you're going to notice our x is just how many years out we are from our starting point. Okay, so at 10 years out, we would plug in 10 there for x and add that all up. So 22.8 plus 105. Okay, so we did the math over here. So we'd say y equals 333 when our x is at 10. So 10, 333, and yep, that goes to about that spot. So we can see how much power is increasing each year from these renewable sources. And here are their calculations. They did about the same thing. So there we go. Ta-da! 333. That's the magic number. So, wow, if you're ever an electrician, 120 bucks an hour, you better own your own company. They make a lot of money, but they also have to be very skilled at what they're doing. So if you know kind of the fee to just show up, right? That's going to be your y-intercept. So the initial fee is 50 bucks. And if you were to write a linear equation, oh, they don't make 120 an hour. Sorry, after 2 hours of work and 190 after 4 hours of work. So you're figuring out the slope, then you're figuring out how much they charge to just show up if there was an initial fee, and what the cost is per hour. So they're charging 35 an hour plus 50 to just show up, which is incredibly cheap. You'll never find anybody to show up at your house for that price ever. Good luck with that. So the moral of the story is slope-intercept form will help you model real life equations, real life situations, and find um, how much to pay people, how much your business should be earning, and all kinds of other glorious things. So learn that slope-intercept form, y equals mx plus b, and it will help you for the rest of your life. Bye!